Okay, so we're going to complete the square. And before we complete the square, let me just review you for just a minute. Completing the square is forcing a perfect square trinomial. So if you'll think back, a perfect square trinomial is a quadratic that has the form, let's see, I'll do 1 plus and 1 minus. If I had something that looked like this, so the ends are both perfect squares, right? Because the square root of x squared would be x, and the square root of 9 would be 3. And if you can take these two values and multiply them together, so together that would give you 3x, and double it, it gives you what's in the middle. Okay, so that's kind of your check. The second sign's always plus, but the first sign can be plus or minus. But this is your big check here. It's the square root of the ends, okay, multiplied and doubled gives you what's in the middle. If that's true, then it's an easy factor. You take the square root of the first, you take the very first sign, so if that had been a minus first, this would be a minus here, and then you take the square root of the end squared. So a perfect square trinomial is nice because it factors into a square of a binomial easily. And just to show you that that first sign could be either plus or minus, it really doesn't matter. If this was x squared minus 6x plus 9, again, the square roots of the ends multiply and double to give you 6x. So it would factor as the square root of the first sign, and then the square root of the last term squared. Okay, so it's an easy factor, and that's why we like perfect square trinomials. So completing the square is when we take a quadratic that's not quite a perfect square, but we're going to make it a perfect square. So let's say I had x squared plus 10x. And I said, what could I put in this space that would make this a perfect square trinomial so that I could easily factor it? And so there's a little formula you can use. If you recall, generally our quadratics are ax squared plus bx plus c. So I'm going to call this c, my missing value. So here, to find that c that works, that makes it a perfect square trinomial, I want to take the b that's in the middle, and I want to cut it in half, so divide it by 2, and then square it. Okay, and this allows me to complete the square, to complete this quadratic so that it becomes a perfect square trinomial. So in the case of my example here, I would have 10, because that's my b, remember b is hooked to the x, divided by 2 and squared. Well, half of 10 is 5, and 5 squared is 25. So in this blank, if I put 25, now it becomes a perfect square trinomial. So just a check as to what we know it means to be a perfect square trinomial. The first term is a perfect square, the last term is a perfect square, the last sign is a plus, and then I want to check. The square root of the first is x, and the square root of the last is 5. If I multiply those together and double it, do I get what's in the middle? And I do, which means it is a perfect square trinomial. So to factor it, I do x, remember, always take that first sign, plus 5 squared. So this we use here. I'm not solving anything just yet, and I'm kind of setting you up to solve something here. So let me show you how we use this to actually, I went the wrong way, to actually solve. So let's say I had x squared plus, actually let's make this one minus so we're a little bit different. Alright, x squared minus 8x plus 6 equals 0. And so my question to you is this a perfect square trinomial? Could I factor and solve it the way it sits now? Because my directions say solve by completing the square. Well, if I look, my check wants to be here. Remember, the two ends must be perfect squares, so that's my first check. So this is clearly a perfect square, but 6, no, that's not a perfect square. So right off the bat, I see, oh, this is bad. Okay, this is a bad C. I want to find a good C, but because I'm in an equation, I got to keep everything moved around right. Okay, so, or not moved around, but I got to keep everything balanced. I'm sorry. So if I want to move this 6, this bad C, what I want to do is make sure I move it on both sides. So I'm going to subtract here, and I'll have x squared minus 8x. Now I want you to notice what I'm going to do here. I'm going to still say plus, but I'm going to leave a blank here because I'm going to do that complete the square here so that I can easily factor. So here I'm going to have negative 6. And I'm going to do the same over here because remember it's an equation, I've got to stay balanced. So if I add it to the left side, I'm also going to have to add it to the right side. All right, so now the question is, what could go in this blank that would make that a perfect square trinomial? What could I put there so that I could easily factor? Well, so if we use our little formula, which remember was b over 2 squared, and you don't have to worry about the sign on the b because when you square it, it's going to be positive anyway. So I'm going to have my b is 8 over 2 squared, right? So 8 divided by 2 is 4, but I have to square it, so I get 16. So my good C on both sides is going to be 16. Again, I got to stay balanced, so if I add it to one side, I also have to add it to the other side. All right, so now I have a good C. It's not bad anymore. So now what I want to do is I want to factor the left side. So put you some steps. Let's see. So here, this is where we moved the bad C. And here is where we completed the square. And I'm just going to put CTS here for complete the square. So now it's just a matter of factor and solve. So on the left, remember to factor a perfect square trinomial. It's the square root of the first, it's the first sign, and it's the square root of the last squared. And now if I look at the right, what's negative 6 plus 16? And I hope you all can get that. That is 10. Okay, so now to solve this becomes an easy solve. And I'm going to go to the next page, so I've got some room here. To solve, goodness, I keep going the wrong way here. X minus 4 squared equals 10. Remember, we go opposite order of operations here to solve. So I'm going to take square root on both sides. So I get x minus 4. Now remember, because this is a square root, I really want to do my plus or minus because it could be the positive root or the negative root. And I want to check this. Can I simplify this any? Can I split it up, break it apart? Is it divisible by any other perfect square? The answer to this is no. 10 is already a perfect square. So all I want to do now is add 4 to both sides. And so what I have is I have x equals, don't combine these two values because 4 is not under a radical and 10 is. So I have a positive 4 plus or minus the square root of 10. And it's solved. Now a couple of reminders. Just as you work through the lessons, you will encounter some problems that you have to simplify that square root. So let me just remind you here for a second of how you simplify a square root. So if I have the square root of And I'm going to actually make this negative, so we kind of review our complex numbers to negative 50. Remember, anytime you see a negative, the square root of negative 1 is imaginary, so it's I. So anytime you see a negative, you just want to pull out that I. So now we want to look at this number and see if we can divide by a perfect square. So let's think about our perfect squares. We have 2 to the second is 4, 3 to the second is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. And so of these numbers, are there anything that go into 50 evenly? Yes, there is 25. So I would take 25 and 2, because that's what multiplies together to give me 50. And so this would give me, and I'm just going to write it, generally we put the whole number in front of the variable. Square root of 25 is 5, I, square root of 2. Okay, so just a quick recap on simplifying radicals there, and in this case it was a negative under the radical, which meant I had an imaginary number. So just be careful as you complete the square that once you get to this point, if you have a radical that can be simplified, that you do go ahead and simplify that also.